Hello everyone. Welcome to episode 3 of our DBMS video series. In the past video, that is the last episode, we talk about data abstraction and data independence. But today, get ready for something delicious. We are going to learn DBMS architecture using a restaurant analogy. Yes, you should never forget DBMS architecture after this video. Let's get started. Part Imagine you go to the restaurant because you are hungry. You sit at a table, look at the menu, and place the order. Behind the scene, many people are working to serve your food. Similarly, in DBMS, many components work together to handle your query. So let's understand how DBMS architecture works just like how a restaurant works. This is the system architecture of database management system. Here you can see four types of user: naive user, application programmer, sophisticated user, and database administrator. Naive user can be a web user, it can be agent, it can be a tailors. Application programmer who can write an application program. Sophisticated user is one of the analysts who can provide a DML queries directly to the database management system. Data administrator is the main user or owner of database who can provide the DDL queries directly. Below these four types of user, you can see four types of user interface. The first one is application interface. It means it can be forms, it can be reports by which naive user can interact with DBMS, that is database management system. Application programmer can write an application program and interact with DBMS, whereas the sophisticated users are writing DML queries submitted to DBMS. Database administrator uses administration tools like DDL commands to interact with database management system. If you are observing here, entire DBMS is actually combination of two parts: query processor and storage manager. So this diagram is divided into three parts. The first one is user interface. Second one is DBMS, that is database management system, comprising of query processor and storage manager. And the last one, that is third one, is disk manager. In case of query processor, application program object code is actually given and it can be directly given to query evaluation engine. The job of query evaluation engine is to evaluate the query and submit that particular query to storage manager. Compiler and linker. When the application program is given to the compiler and linker, it compiles, means it converts that application code into lower level and link it with various library. If that particular code has DML queries, in that case that DML queries will be separated and it will be given to DML compiler and organizer. DML compiler will convert this DML queries into low level and submit it to query evaluation engine. In case of fourth user, it will provide the DDL commands to the database management system, where DDL interpreter will convert this commands and directly execute and directly interact with disk manager. Next component is storage manager. Storage manager has four types of different manager: buffer manager, which take care of temporary space needed to evaluate the query; file manager, that helps interact with disk manager and provide data or indices to the query for evaluation; authorization and integrity manager will take care of, and integrity manager will take care of authentication as well as take care of the integrity. Transaction manager is responsible to manage all kinds of transactions happening into the DBMS queries. So this is entirely storage manager. And the last one, that is the lowest level, is disk storage. Disk storage is comprises of four blocks: data, actual raw information, indices, indexes, data dictionary, data about data, and statistical data. So welcome to DBMS restaurant. Now I'll correlate all these blocks that we have seen into this database system architecture of database. Well, see, the analogy, that is DBMS, is treated as restaurant here. The way I have said earlier, the topmost layer is of users, the second layer is of user interface. This topmost layer is represented using an analogy like naive user will be treated as walking customer. They just order from the menu without knowing how food is prepared. Application programmer is acting as chef. They write a recipe that makes the food. The third one is sophisticated user is treated as food critics. They use advanced tools to check recipes and try new combos. So they will write a new custom queries. Database administrator will be treated as restaurant manager. They will ensure smooth operation, maintain quality, handle permissions and ingredients. Coming towards the next layer, that is user interface, application interface will be treated as a menu where menu card will be shown to the customer. Next will be application programs. It is as good as writing recipes. Query tools will be a custom queries and administrator tools will be like manage all operations of the top layer. Let us look at the detailed thing. Naive user, as I said, it's a walking customer. Application interface will be a menu card, and with the help of menu card, the waiter will take order from customer and that order will be executed in this way. Here you can see that the application program object code will be like our waiters. Then compilers and linker will be order translator. DML queries will be food tickets. So this food tickets will be generated by sophisticated user. DDL interpreter will be recipe master who can write a new recipes. Query evaluation engine will be head shape. DML compiler or organizer will be order dispatcher. Buffer manager will be pantry organizer. File manager will be inventory staff. Authorization and integrity manager will be quality checker. Transaction manager will be shift manager. In case of data storage, data will be treated as raw or ingredients. Indices will be recipe shortcuts. Data dictionary will be kitchen handbook. Statistical data will be sales and order trends. So entire disk storage will be treated as store. Query processor will be treated as order executor. Storage manager will be a pantry boss. So here you can understand the entire, the namings, how we have renamed it to each and every block. So let's look at this. The walking customer will come. It will look at menu card. It will order the waiter. Waiter will take that order and that order will be translated to food tickets. That food tickets will be generated and given to order dispatcher. Order dispatcher will submit that to head chef. Head chef will actually take care of preparing entire food with the help of pantry organizer, inventory staff, then it will shift manager. So this way this entire work will go on. Here you can observe that pantry manager will definitely take the ingredients and that will be provided to the chef. Recipe shortcuts, here you will get a recipe by which the chef can prepare a food. Kitchen handbook will again serve as to the head chef to prepare a food, and sales and order trends where people will observe that what kind of things are actually needed and that entire thing will be taken care of this head chef. So head chef is the main block which is acting as a query evaluation. Again, I have told you that the topmost block of DBMS will be known as query processor, can also be known as order executor in our case. The second lower level is storage manager, can be known as pantry boss, and the disk storage will be treated as what? The store. So friends, you can observe here that we have actually managed everything with the help of this block. Order will be executed from customer to dish. Customer will order to the waiter. Waiter may directly submit that particular order to shape, or waiter may submit that order to query processor. Query processor will be helpful to the execution engine to make the entire plan of execution, and execution engine will take care of the storage manager, and finally the result will be given in the form of dish. If you are observing these two important parameter, the head chef is actually acting as a DDL interpreter. It reads the new recipe and teaches it to the team. This is like when we use DDL to create or modify the structure of database. On the other hand, you can observe the Soshev, that is our DML compiler, translate your food order into the cooking steps. This is like converting your queries into execution plan. So both are very important component. Maybe with a quick question, who is the pantry boss in our analogy? Option A, query optimizer. Option B, DML compiler. C, storage manager. D, execution engine. Comment your answer below. Thank you for watching episode 3. If this video helped you understand DBMS architecture better, please like, subscribe, share it with your friends, and see you all in episode number 3, where we will learn about data models, a super important topic. See you there. Bye bye and happy learning.